Hi everyone, welcome to our channel Dr. VKR all about civil engineering. Today we are going to discuss about an important famous personality and brilliant mind of mathematics. Today the date is December 22nd. It is celebrated as National Mathematics Day. Do you know why we are celebrating this National Mathematics Day? To honor one of the youngest minds of mathematics. Pure genius is nothing but none other than Srinivasa Ramanujan sir. So we are going to discuss about him, how he has influenced the civil engineering field. And remember, he was not a civil engineer. He not even designed or constructed a dam, bridge or even a small structure also. But why we need to discuss about him? Because the young minds of mathematics like him have shaped the mathematics further, and because of that mathematics formulas influenced the applied sciences a lot, including civil engineering also. That's why we are going to discuss about Srinivasa Ramanujan sir, how his inventions shaped the civil engineering, what we are having now. Let us deep dive into the actual content. Before going to the content, I request everyone to like, share and subscribe our channel. Thank you. Now let us discuss about Srinivasa Ramanujan sir's life history first. So, he born in the year 1887, December 22nd in Erode, Madras Presidency. Now we are calling as the Madras in Tamil Nadu. So, what is the importance of his life is he is not having formal education first of all. Without formal education, and at that time it is very difficult and it is very limited to have the formal education also, but with having all these constraints, he developed himself as a pure mathematician because of his pure passion and his thinking abilities. So at the age of 16 he mastered the advanced mathematics by going through the G.S. Carr's synopsis of elementary results. By going through that book, he learned so many things and he mastered the advanced mathematics also. So in 1907, he fails college examinations because he is not having the interest in other subject. His interest is only mathematics. So in 1911, he publishes his first research paper in the Journal of Indian Mathematical Society. Do you guess what is the topic? It is Bernoulli's numbers. So on Bernoulli's number, he published his first research paper in 1911. Then in 1930, he wrote the famous letter to Professor G.S. Hardy, who was the British mathematician. And in that one, he has given all his works, including 120 theorems and results. Just understand how much work he did before without any formal education also. Then in 1914 he received a letter from the G.S. Hardy and invited Srinivasa Ramanujan sir to Cambridge University, and he went there, and there he started formal research collaboration. That is a turning point to give more of the research related to the mathematics. So in 1914 to 1917 he stayed there in the 3 years, and he worked on various aspects which totally changed the way of thinking of the mathematician, engineers and everyone. Those topics are infinite series, number theory, partitions and continued fractions. And remember, during this period his health was not in a good condition. And in 1917 he develops major results on partition functions. So later this fundamental to analytical number theory, whatever we are having analytical number theory, it is mainly because of the Srinivasa Ramanujan sir's partition theory. So this is in the year of 1917, and in the 1918 he elected as Fellow of Royal Society, one of the youngest fellow and the first Indian mathematician to get this honor, please remember. And then in 1980 he elected as the Fellow of Trinity College, Cambridge in 1918. And 18 to 1919 he worked on one of the most important topic as mock theta functions, a concept fully understand after some decades only. Just understand how advanced his thinking abilities are, how far he thinks about the mathematics, how well he understands the mathematics also. So in 1919 he returned to India because of his health condition, and he passed away at the age of 32 due to his health conditions in the year 1920. Now after this one, Professor Hardy has collected all the works of the Ramanujan sirs, and he published a book along with the help of other peers. Then in 1976 there is a book released, Discovery of Ramanujan's The Lost Notebook, that is going to be encouraging or inspiring the research even in 21st century to get the new research ideas. That's how he inspired the generations with his mathematical abilities also. Now, so if you observe in detail about his journey, whatever we have discussed, it's a crisp of his life. Now let us understand how, at what stage he contributed to the civil engineering. Now in the early mastery of advanced mathematics, as we discussed, it is from 1903 to 1904. So there he has the basic foundation to influence all the fields of engineering. So basic thing is having deep understanding of basics, where in the present generation we are lacking that one. For anything to understand, we need to have some basic fundamental understanding, then only we can excel in that particular field. He is having that knowledge, basic fundamentals. So here if you observe the civil engineering, at that time there is no softwares, but they are having the designs and everything, and the structures are sustaining also. Always remember, fundamentals are more than the tools. Even whatever the tools we are having for the analysis and design, whatever we give, it will give some result. It doesn't work like that. How well you give the input, based on that one you are going to have the output also. So like this we need to understand various things. Now let us discuss his research works in detail. So as we discussed, in 1911 he published the article on Bernoulli's number. So how this Bernoulli's number is going to be related to civil engineering? That's the main question. Now just understand. So he published the paper with the Bernoulli's numbers, which are closely linked to series expansions and number approximations. We are having the series expansion and number approximation. In civil engineering, series expansions are oftenly used to model various things. What are the things we can model using the series expansion representation is load variation over time, bending and deflection behavior for every structure. It is very, very important. Dynamic response of structures, whatever we are seeing now, dynamic seismic response, how it is going to behave, everything we are going to depend on the series representations only. That is given by first Srinivasa Ramanujan sir. And when the engineers approximate the real world behavior mathematically, please understand, so far in the previous one we designed the members based on the experience and thumb rules, but when we start designing the members based on the mathematical equations and that to approximations, then this is going to change the way of thinking of the engineers to design the. So as we discussed here, he wrote a letter to Professor Hardy in 1913. So in that one, major works he presented is pattern recognition in engineering. Pattern recognition, is it really required? And in that including the partition theory also. So just understand, are these two, first glance, what comes into your mind when I say partition and pattern recognition? Is this going to be relevant for the civil engineering? You may think like it seems to be relevant, but not. It is going to be relevant to civil engineering field. So the modern civil engineering systems, if you observe, most of them are complex in nature, and loads are not carried by single members. We are having so many of the structural elements are there, multiple members, beam, column, slabs, beam, column, slabs, footings, everything is there, soil is also, and we are having the redundant load paths. We can't say in which direction it is going to be passing. Load is going to be transferring, and sometimes the members may not take the load, the surrounding members may take care of the loads also. And interacting subsystems like soil structure interaction, how one system is going to be interacting with the other system. So all these things underlines the load distribution analysis, what we are using now, progressive collapse studies, one of the most important aspect of the analysis, structural redundancy evaluation. So all these things are linked to again pattern recognition and partition theory. Do you assess or do you evaluate all these things without his partition theory? No, that's the basic. From there only everything has been derived by the other scientists and the mathematicians. So here, whenever engineers assess the failures now, how a failure is going to affect the other. For example, if I take the beam, column and slab and substructure foundation, how the failure of the slab going to affect the foundation, or how the failure of the foundation affects the beam and column behavior. All these things are going to be interlinked with each other. So this is going to be one of the important critical point of analysis for the any infrastructure point of it. Then coming back to his research period in Cambridge from 1914 to 1917. So mainly he worked on infinite series and approximation. Do you believe? This is the backbone of structural analysis which we are using now. The backbone of structural analysis for all the structures is infinite series and approximations only. So now, why does this matter to civil engineering? How this is going to be useful? Here, the infinite series and the approximations mainly based on the convergence pattern. So if I want to go for the realistic solution, I need to converge at a faster rate. So when compared to the other experts or the other mathematicians, he used to get close to the solution in real quick time with less number of iterations. That's how his brain works also. So in structural engineering, we analyze the vibrations of the beams, buildings, we are solving the differential equations, everything we are doing. So these equations almost never have the exact closed form solution. Do we have? No, obviously. Then we are solving this one in the series expansions. So there the brilliant mind of Srinivasa Ramanujan sir comes into the picture. So if I take a small example for clear understanding these things. So in general, building vibrates during the earthquake. Everyone knows building vibrates during the earthquake. So its motion is break down into number of small particles, multiple vibration modes, and each mode is going to be evaluated or assessed separately by using the mathematical series terms. The faster those series converge, then the more accurate and the less time is required. So we are going to rely on that type of the solutions. From where we got this type of solutions? This is again from Srinivasa Ramanujan sir. So mainly we are focusing on structural vibration analysis, dynamic response calculation, stability studies of slender structures, everything linked to this infinite series and approximations. So here, without him, it is very difficult for us to assess all these things. The foundation stone has been laid by Srinivasa Ramanujan sir for this type of the structures. Then, so if you observe, the next one is 1918 to 1919. So he worked on one of the most important aspect, mock theta functions. It is nothing but asymptotic analysis. Just understand, in general we are going to design our structure to sustain extreme condition. It may be of a seismic activity, it may be of a cyclic winds, it may be of a overloads or accidental loads coming onto the structure. Now when I am going for extreme conditions, it's very difficult for us to have the mathematical model. So there he comes into the picture. So in general he deals with the nonlinear systems, whatever this one, including the earthquake response, oil structure interaction, nonlinear material behavior, everything we can have with this asymptotic analysis. And here if you observe, so the mainly becomes very essential. If you observe this asymptotic analysis, it is going to be very clear picture nowadays that we are going to use these things in the nonlinear structural analysis, plastic hinge modeling and collapse prediction. So In the plastic information we are having this one, and to model that one we need to go for the asymptotic analysis. And similarly nonlinear structural analysis, because most of the times we are designing the structures for this nonlinear condition only. Those are the days gone where we are going for the linear analysis. Now next, he, as we discussed, he elected as fellow of Royal Society Mathematics as an engineer backbone. There he got the support, and he have the all the information, and he gave that to the society also. So in general, if you observe the entire spectrum of civil engineering, it stands mainly on three pillars. If I say with respect to the other aspect, like physics, materials and mathematics, these are the three pillars of the civil engineering, based on which everything has been constructed and derived also. So recognition at this level reinforces the truth that engineering progresses only when mathematics progress. Without all these mathematical formulations, can we expect the progression in the civil engineering? Advanced analysis, your soil structure interaction, nonlinear analysis, plastic inch modeling, all this? No, we don't have all these things. Once the mathematical progression or innovation stops, then civil engineering stagnates. We are based on the civil mathematics only. So then you just observe his works, like book Lost Notebooks discovered 1975. It is having long-term impact on engineering computation. Even now, people are doing the research on his works, how he arrived with that very small number of steps, how he analyzed everything. Because he is the one who doesn't follow the traditional conventional procedure to solve the problem. He is going to think in the different directions, and he is going to have, there is no logic behind his problem solving also. Because of that, beyond the thinking abilities, he derived the solutions at a faster rate when compared to the other researchers also. Now even though he lasted for only 32 years, but he left the long lasting legacy. Because of him we are having all these things. Even now we are discussing about him because of the works he has given to the society, on which we are designing and constructing all the infrastructure projects. Let us discuss the other aspect also. Now, by observing all these things, what he has given, he contributed to the capacity of what? Capacity to model complexity. Because of that one we are modeling and analyzing any complex structure, so that we are going to implement in the field. Then he has given the capacity to approximate reality. Very important, because in the civil engineering it's very difficult to get the exact realistic behavior. We need to go to with as much close to as realistic behavior, but it never happened, the real behavior. So we need to approximately very close to the real solution. That how it comes, it is from the approximation theories only again. Then he has given the capacity to think mathematically under the uncertainty. In civil engineering, do you have any certainty of the stability of the structure or failure of the structure? Previously we are going to have the when this going to fail, but now we are not thinking of the failure, whether it is going to sustain, whether it is going to lasting for a given period, whether it is going to sustain all the extreme forces. All these things we are discussing. All these innovations and changes are mainly because of the works done by the brilliant mathematician from our India, nothing but Srinivasa Ramanujan sir. Want to have a safer structural design? It's not about the code, it's about the person who understands the mathematics well, because all these things again depends on the mathematics only, all entire civil engineering. Because if you consider the civil engineering, we are having various aspects of structural analysis, fluid mechanics, soil mechanics, all this involves in the mathematical calculations only. It's very difficult to analyze and arrive the exact behavior without any approximations. It's very difficult. So from his works we learn so many things, and still the research is going on his works, which are going to be contributing to the society for the benefit of the society even till today also. So codes do not make structures safe. It is the engineer who understand the mathematics too. Please remember this one. As a civil engineer, it is our responsibility to understand the mathematical concepts basics level, and based on that one only we need to go for the modeling, analysis and design of any structure, any material. Civil engineering means not only structures, any material. It may be of concrete, steel, soil, anything. So this is all about the importance of Srinivasa Ramanujan sir's work related to the civil engineering. Hope you got some new insights on this one. If you need any topic, or if you need anything to be discussed, or if you have any doubt, please keep it in the comment section and we will come back to you. I request everyone to like, share, subscribe our channel, Dr. VKR, all about civil engineering. Thank you all.